Hello to you. I'm Jessie R. Johnson. I'll be speaking to you today about propulsion, specifically enclosed propulsion, type 2. This is photon laser thrust enclosed propulsion. There are two types of propulsion forms, open and enclosed. Open propulsion means that energy can enter and or exit the bounded space that makes up the system and make the system accelerate and move. Open propulsion includes such for land, such as automobiles, for water, such as submarines, for ice, such as ice-breaking ships, for air, such as planes and jets, for space, such as rockets. Enclosed propulsion, on the other hand, means no energy enters or exits the system or the bounded space upwards of 99% or more. This type of propulsion system includes several types. The one that shall be illustrated and explained here is type 2. This is to prove that such types of systems are in fact possible once the technology, the machinery, and the mechanics become advanced enough. The first enclosed type used graphene propelled by light. The second enclosed type uses mirrors propelled by light. Only when the machinery and the mechanics become advanced enough in miniaturization will this type also work. Right now, many parts are too large and bulky, but not that much so. The illustrations that shall be shown are purposely kept simple. Please hold on. I'm going to move the camera. Now, to begin, thank you for waiting. This here is illustration A. It shows a side view of such a propulsion system. Numbers 1 and 2, along with numbers 3 and 4, 3 and 4, 3 and 4, are super lightweight, high-reflectance mirrors. Numbers 3 and 4 are at 40 to 45 degree angles, and slanted to reflect laser light. Number 8 is the laser light in blue. These are the laser beams. And numbers 5 and 6 are the Photon Laser Thrusters. 5 and 6 are Photon Laser Thrusters. And number 7 is the super lightweight total housing. The total housing, which is composed of and includes numbers 1 through 8. Now, numbers 5 and 6, which is the Photon Laser Thrusters, are turned on and sends out. These are the Photon Laser Thrusters. They are turned on from the 5 and 6. They are turned on and sends out laser beams, number 8. It sends out number 8, laser beams of specific frequencies and of specific wattage power. Now, of which the laser light reflects back and forth between numbers 1 and 2. 1 and 2 reflects back and forth, and between 5 and 6, back and forth, between 5 and 6, between 2 and 6, 2 and 6, via number 3 and 4, the slanted mirrors here. Number 4, respectively. Now, the photons accumulate and continuously build up in number from being reflected in this way by the mirrors. Back, forth, back, forth, back, forth, back, forth, back, forth, back, forth in blue here. And until this massive photons buildup creates enough macroscopic, that's MAC, macroscopic physical force of push to physically move numbers 1 and 2, super lightweight high reflectance mirrors, which moves number 7, which is super lightweight total housing, as a total whole in direction A, as shown by the green arrow here, direction A. Now, since number 8, which is the laser beams, number 8 here, which is the laser beams in blue, are reflected from numbers 1 and 2, to number 3 and 4, to number 5 and 6, 5 and 6, respectively, to produce photon accumulations, then the momentum is conserved in the direction of B and C of numbers 5 and 6, or the photon laser thrusters. The light builds up in photon physical force momentum, and the momentum must be conserved. This goes up, and this here is reflected, so therefore the 5 and 6 must go in direction C, as the green arrow shows, and 5 must go in direction B, as the arrow is shown here. Now, the downward force of momentum, since the light is being reflected off of number 3 and 4, the downward force of momentum of numbers 3 and 4, the super lightweight, high reflectance mirrors, is negligible. It is very little of it, in fact. Very little force is being forced downward. It is negligible. Now, since number 8 is here, the blue laser beams are being reflected with over 99% reflectance because of this. Now, the light is deflected. It is deflected, or is made to change course. But it is made to change course by reflection of the mirrors, or moving the light in another direction without absorbing it. Now, since this is an inelastic collision between light beams and mirrors, there's virtually no momentum imparted to make it go downward. Now, illustration B. This is illustration B. Illustration B is a top view of the photon, top view of numbers 1 and 2, the super lightweight high reflectance mirrors, enclosed in number 7. Number 7 is here. Enclosed in the super lightweight total housing. Now, this is illustration C. Illustration C. Illustration C shows the PLT, or the Photon Laser Thruster mechanism, or the Photon Laser Thruster mechanism. This has a number 8 laser beams in pinkish red here, put between the super lightweight high reflectance mirrors of numbers 1 and 2. Numbers 1 and 2 are mirrors. Numbers 1 and 2 are mirrors, and here's the laser beams going back, forth, building up, accumulating nothing but photons, which reflects several hundreds of times back and forth continuously, accumulating photons. The photons build up between the mirrors and creates direct momentum imparting, and physically pushes the mirrors in opposite directions from each other of A and B, as shown by the green arrows. A is here and the green arrow is this way. B is over here and the green arrow is going that way. And now the photon laser thrusters have existed over a decade, but not in extreme miniaturized form. But when they do, this specific propulsion system will be possible. I want to thank everyone for watching and listening, and have a very good day.